Welcome to Pico to Mega and Back, a scientific notation for amateur radio by David Okren, W7DAO. Scientific notation makes expressing large numbers easier and more compact. As you can see in the box, we have is a format of a number or a coefficient multiplied by base 10 raised to a power. So for example, it could be 3 times 10 raised to the power of 2. And that's the basic expression for scientific notation. And for example, we can write 89 million, which is 89, 000, 000, every time it needs to be expressed, or use 89 times 10 to the 6, meaning 89 followed by 6 zeros. Or, to make it even more compact, we can use 89 mega, where mega means times 10 to the 6. So it becomes much more compact and easier to express very large numbers. Another example pertains to small numbers. We could write 0.000000000012 every time we need to express it in the course of one equation, or we could use 12 times 10 to the minus 12 power, meaning a decimal point followed by 10 zeros and then a 12. Or 1 pico, where pico indicates times 10 to the minus 12. So by using scientific notation, we can express these small numbers in a much more compact way, and replacing the power of 10 by some terminology that's been accepted across the world, we can use things like mega and pico to further compact the expression. Before we get into this in more detail, let's review the idea of places. So we have a number here, 4,123.891. And we can identify what the ones location is, and that indicates 3 times 10 to the 0 power, and 10 to the 0 power is actually 1, so the equation would be 3 times 1 equals 3. We can move over to the left and we have the tens place, and here we have 2 times 10 to the first power, where that indicates 2 times 10, or here we have 20. And then the hundreds power is 1 times 10 to the second power, which means 1 times 100. Equals 100. And then going over to the thousandth place, we have 4 times 10 to the third power, and it's basically 4 times 1,000, or 4,000. We can also go to the other side of the decimal place and go at tenths, which is 8 times 10 to the minus 1, and minus 1 here indicates 0.1, so it's 8 times 0.1 equals 0.8. We can then move over to the hundredths place. That's like 100. That's like a fraction, some number, in this case 89, over 100, which is 9 times, in this case, since it's the hundredths place we're dealing with, it's 9 times 10 to the minus 2, or 9 times 0.01. And the next place over, the thousandths place, is 1 times 10 to the minus 3, which again is going to be another 0 added, so 1 times 0.001 to get the answer, which would be 0.001. So these are all the different places, and these are how each place is expressed in scientific notation. If we add up all the expressions that are in blue from the left side to the right side, then we'll get 4,123.891. Now, we would not write out this number as we did in the blue expressions all added up together. We might use something like expressing it in 4 times 1 times 10 to the third power, where we would then round the number up so that it would be a little bit more compact to use. It all depends how much rounding we do. Really just depends on how much precision we want in the measurement or in the calculation. So terms that we typically use in ham radio that are associated with powers of 10 is pico, nano, micro, milli, kilo, mega, and giga. So pico being the smallest one, 1 times 10 to the minus 12 power, with nano 10 to the ninth minus 9 power, micro 10 to the minus 6 power, milli 10 to the minus third power, and then kilo 10 to the third, mega 10 to the sixth, and giga 10 to the ninth. These are the typical values that we use in amateur radio, and let's look and see how they're used. So first, let's look at the visual breakdown of all this. Starting from the left side, you can see the kilo deals with the first thousandth place. The mega, million places, and giga would be the billionth place. I didn't have that here. And going to the right side, we have milli, which deals with the first three decimal places to the right of the decimal place. Micro, the next 3 or 6 places from the right of the decimal place. Nano, 9 places from the right of the decimal place. And Pico, 12 places to the right of the decimal place. So that's a visual breakdown of how these things work. And also, you'll begin to see in a few minutes that we're really moving leading and trailing zeros around when we're converting these things from one format to another. So for example, for milli, 10 to the minus third, it takes the starting number and moves the decimal place to the right 3 places. So you can see where on the left we have that area that shows what milli it basically pertains to. The first 3 places, specifically 10 to the minus third, which is the third place over. So now what it means is we're going to move the decimal place. We convert this from the raw number 0.0035 to milli. We're going to move the decimal places 3 times. The gray arrow indicates the original decimal place. The blue arrow indicates the new decimal place. So we move it over 1 and we get 0.035. We move it over again and get 0.35, and we move it over the third time and get 3.5. And so that would be then 3.5 milli. So all we're doing with these things is moving decimal places to the right when we're doing with any number less than 1. So in this case, 10 to the minus 3, we're moving over 3 decimal places. 10 to the minus 6, we're moving over 6 decimal places to the right. Now the other side is also true, but we're going to be moving to the left. So if we take kilo, which is 10 to the third, it takes the starting number and moves the decimal place to the left 3 places. So we're going to go right for anything less than 1, and we're going to go left for anything greater than 1. So you can see kilo is dealing with the thousandths place, and as we see as just before, the gray arrow indicates the original decimal place. The blue arrow indicates the new decimal place. We're going to move it over 3 times, and we're going to end up with 3.4 kilo, because 3.4 kilo means 3.4 times 10 to the third power, or 3.4 times 1,000, which would be 3,400. Just as before with 10 to the minus 3, we would end up with 3.5 milli, which means 3.5 times 10 to the minus third power. So here are some examples, and we can recognize one already. On the far top left, we have 0.0035, and I've added a lot of zeros on the other side just to show you that it doesn't really matter how many zeros we put in at the right after the number, but it's helpful when sometimes converting from milli and micro and nano and pico to put all the extra zeros in so you can just really keep track of where the decimal point is moving. So here we're going to move the decimal point over 3 times, and we're going to get 3.5 milli. We have 0.250 milli, and you can see that looks like, just taking an eyeball, it looks like 250. If we move the decimal point over 3 times, we end up with 250 milli. If we have pico, which is 10 to the minus 12, and we move it over the decimal place 12 times, we move it over 12 times to the right, we get 9,000 pico, because the decimal place that we're moved over will end up to the right side of the final 0. On micro, we have 0.0035, whatever the unit is here. I didn't put any units on. How do we convert that to micro? Well, remember it's 10 to the 6. We're going to move the decimal place over 6 times. So 1, 2, 3. The third place is going to be 3.5. 4, it's going to be 35. 5, it's going to be 350. And finally, the sixth place will be 3,500 micros, which means 30,500 times 10 to the minus 6 power. Nano, we're going to move over it now 9 times because it's 10 to the minus 9. And as we move over, we'll end up with the decimal place ending up on the right side of the 9, which is 9 nano, which is equal to 9 times 10 to the minus 9th. And again, we have picos again, and we move the decimal place all the way over 12 places to the right. We end up with the decimal place to the right of the 4. So we get 4 pico, which is 4 times 10 to the minus 12. So we can convert a number, as you can see, top to bottom here, from the left side, left column, the first column we converted to 3.5 milli, but the same number, the exact same number, can be expressed as 3,500 micro. When you multiply it out, they will end up being the same numbers. just as we see the final column on the right top, Pico, says 9,000 Pico. If you look at the column in the middle second row, that 9,000 that you appear in the Pico up there can be expressed as 9 nano because we moved, instead of being 10 to the minus 12, we are now 10 to the minus 9, and we've moved the decimal place to the left instead of the right this time over. If we were going from Pico to nano, we moved over 3 to the left. If we were going from just the number to nano, we go over from the left 9 places instead of from the right. So that's how you can convert back and forth. What's Pico, what's nano? Just write it all out and count up where your zeros are and where your decimal place is moving, and it becomes very clear where you are. On the other side, we look at kilo, for example, and this pertains to other measurements as well. Anything greater than 1, we're going to go to the left. So here we have kilo, and here we have a number with 1,234. It can be, we're not really getting any advantage by saying 1.234 kilo, which is 1.234 times 10 to the third power. And oftentimes we'll round that number up to 1.2 kilo if we don't need that much precision. In kilo, we also have 43,200. And you can see as we move the decimal place to the left 3 times, we end up with 43.2 kilo. That's 43.2 times 10 to the third power, or 43.2 times 10 times 1,000. And so we have something like 245, which is less than 1,000. We're still going to move the decimal place over to the left 3 places. We're going to get 0.245 kilo, or to round it up, we get 0.25 kilo, which is 0.25 times 10 to the third, or 0.25 times 1,000. And 2.25 times 1,000 is 250. And then we have mega, which is 10 to the 6th power. And here we move the decimal point over to the left 6 times, and we end up with 23 mega, or 23 times 10 to the 6th, which is 23 times 1 million. And again, moving over to the next one, 4,600,000. We're going to move over the decimal point to the left 6 times and get 4.6 mega, or 4.6 times 10 to the 6th power, or 4.6 times a million. And then finally, if we have a number less than a million, just as we did with kilo less than 1,000, we have 600,000. We move the decimal place over 6 times. We get 0.6 mega, or 0.6 times 10 to the 6th power, or 0.6 times 1 million. So these are all different ways of manipulating the scientific notation and putting in the proper shortened term, kilos and megas and nanos and picos, etc. Now you will see oftentimes in electronics the K in kilo is lowercase. So like in kilohertz, you'll see the K is in lowercase. In frequency megahertz, the M is capitalized. In frequency, the G in gigahertz is capitalized. And the reason for this discrepancy, or I should say this difference, is that there is already a scientific unit that uses the capital K in its abbreviation. So the temperature scale Kelvin uses a capital K, and to differentiate the K from Kelvin for this K, we use a lowercase k. And that's why you'll see 225 kilohertz with a lowercase k instead of an uppercase k. Just a little trivia more than anything else. There is, and this is not part of amateur radio, but you may be exposed to another type of measurement, and that's what computers use for measuring bytes, like memory capacity. They sound similar: kilobyte, megabyte, gigabyte. People will say they have 16 gigs of memory, 16 megs of memory. Well, that's not the same number as what we've been dealing with. The number that computers use is based on base 2, and then the base 2 is raised to a power of an integer. Same basic format, except being base 10, it's base 2, and thereby 1 megabyte is not 6 million. It's a different number because in base 2, we're going to be starting with a number like 1,024 kilobytes as the units. So instead of being 1,000 as, let's say, for kilo, it's actually 1,024 for kilo. And so that's why there's a difference. So when someone tells you it's a megabyte, it's actually not exactly the same number as it would be like a mega in scientific notation or electronics. Just a little difference in case you run across that. But the bottom line here is in scientific notation, we use it to make things compact and easier to deal with when we have very large numbers or very small numbers. And then we have some special names for certain powers of 10 in ham radio. We have the pico, nano, micro, milli, kilo, mega, and giga. Now there are many other names, but these are the many other names for other powers of 10, but we use these primarily. And so hopefully this was helpful, a review of how to use scientific notation and how to apply it to ham radio. If you have any questions, please contact W7DAO at arrl.net. Thank you.